Dear students, in last class we have learned about the introduction of carbonyl compounds. We have seen the structure of aldehyde and ketones. We have also seen how these aldehyde and ketones are reactive due to their polar nature. Then we have just seen they will undergo nucleophilic addition reaction because they have the polar carbonyl group in which oxygen is more electronegative. So electron will move towards oxygen and it will be negative charge, and carbon have positive charge. So that's why carbon act as a electrophile. Then nucleophile will attack, so they will undergo nucleophilic addition reaction. Now today we will see the detailed nucleophilic addition reaction of carbonyl group C double bond O. How this C double bond O will be attacked by nucleophile and how the nucleophilic addition reaction take place at this carbon oxygen double bond. So we know very well that carbonyl carbon has sp2 hybridization with the 3 sp3 orbital from forming overlap with orbital of the one of the oxygen and on the 2 carbon or hydrogen atoms. So in carbonyl group what happened? The carbonyl carbon sp2 hybridized 3 orbitals will react one with oxygen and 2 with hydrogen or alkyl groups. These 3 bonds adopting trigonal planar geometry, thus remaining anhydrous orbital of 2p orbitals will be present in center carbonyl carbon in perpendicular to their plane and thus form a side by side pi bond with 2p orbital on the oxygen. So this carbonyl carbon pi bond formed due to the unhybridized 2p orbitals and they will form the pi bond. Now the carbon oxygen double bond, since it's polar nature, we know very well and we can see that oxygen is more electronegative than carbon. That's why the electron density will move toward the oxygen and it will get a negative charge, and the carbon will be less electro thing. So that's why positive charge will be developed at the carbon. That's why the carbonyl carbon oxygen double bond is a partial polar compound, polar bond, which has partial negative charge at oxygen and partial positive charge at carbon. That's why nucleophile will attack and the reaction will go very easily, nucleophilic addition reaction. Now, if we see the carbon due to electron, its electron pair will act as a electron pool. Electron density is less due to positive charge. They are poor in electron. That's why they can act as an electrophile, and they are more susceptible or they are more prone to be attacked by nucleophilic group which are electron rich. So any electron rich nucleophilic group can act or add on like carbonyl group via the attack on electrophilic carbon. So the carbonyl group will undergo nucleophilic addition reaction very easily. Now, due to oxygen end of the carbonyl one bond bears a partial negative charge, anything can be helped to stabilize this charge by accepting some of the electron density will increase the bond polarity and make the carbon more electrophile. So, due to this oxygen, any group, either it is acid, either it is a metal ion, which bind with oxygen and make oxygen more electronegative and make this double bond to be more polarized to get carbon positive or electrophilic nature more. So any group, any acid or any metal ion or any group which increases the polarity of carbonyl group via the interaction with oxygen, nucleophilic oxygen or negatively charged or partially negatively charged oxygen will increase the reactivity. For example, here acid undergo protonation to the oxygen and increase the reactivity at carbon. In second case, the magnesium ion binds with the oxygen via chelation and make carbonyl carbon to be more electrophilic. This same effect is achieved by Lewis acid or magnesium ion to this. So that's why then after this nucleophile is easily attacked at the carbonyl carbon and we will get the oxonium ion with oxygen. Then later this oxonium ion will undertake proton and undergo protonation and will give you the product alcohols or addition product. Now, after the carbonyl is attacked, the protonation of the from the acid will give you the alcohols. Now, these are very common type of reaction which are called nucleophilic addition reaction. So we can say generally carbonyl compound will undergo nucleophilic addition reaction frequently or commonly. Now, if you see the relative reactivity of carbonyl compound to nucleophilic addition, so we know that aldehyde ketones, how the reactivity will increase. So, in aldehyde, the carbonium ion or the carbon with positive charge will form the primary carbonium ion, which is less stable, more reactive. In the case of ketone, due to presence of alkyl group at the both side, the carbonium ion will form the secondary carbonium ion, which is more stable and less reactive. That's why we can say among ketone and aldehyde, aldehydes are more reactive with compared to ketone, or we can say the aldehyde will go more easily nucleophilic addition reaction, whereas ketone will go nucleophilic addition reaction with less reactivity. Now, if you see nucleophilic addition reaction, any nucleophile will attack on the carbonyl carbon and we will get nucleophilic substituted alcohols. So this is a reduction of aldehyde and ketone. So what happens if you see the reduction means addition of proton, carbonyl group will undergo reduction to give the alcohols. So in this, the first step is the attack of H minus, which is a nucleophile at the carbonyl carbon, and then the electron density move toward the oxygen and we will get the oxonium ion or alkoxide ion. This alkoxide ion will undergo protonation from the water and then we will get the second step, that is the alcohol formation. So the addition of water, or we can say reduction of aldehyde and ketones, is a nucleophilic addition reaction where hydrogens H2 will added. That's why it is a reduction. Now, if you see the strong nucleophiles, for example, anion, add directly to the carbonyl compounds to form the intermediate alkoxide ions, and the alkoxide ion then undergo protonation to give the dilute acid, with dilute acid to give the alcohol. So, in carbonyl compound, irrespective of the nature of the carbonyl group, strong nucleophiles will directly attack at the carbonyl carbon electrophile and give the intermediate, which is called alkoxide ion. Then this alkoxide ion finally undergo protonation either in workup or in the presence of water and will give the alcohols. Now, weaker nucleophiles will require the carbonyl group to be activated prior to attack. So, weak nucleophile directly cannot attack, so they will require the carbonyl group to be activated, or we can say it should be polarized before to undergo nucleophilic attack. So, to do this, we require our acid catalyzed or Lewis bases to get protonation on the oxygen, and then that oxygen protonated oxonium ion carbonyl then undergo nucleophile addition because oxygen cannot contain the positive charge. It is a less stable, more reactive to nucleophile is directly, immediately attack, and then we will get the nucleophilic protonated alcohols. So these are some of the examples are here given. So ethanol or acetaldehyde, acetaldehyde, ethanol will undergo HCl addition, which will give a cyanohydrin, or we can say hydroxypropanonitrile. We will get it. The mechanism is as equal is that this acetaldehyde, this carbonyl group will undergo polarization, partial polarization. Oxygen will get partial negative charge, whereas carbon get partial positive charge. And nitrile, being a nucleophile, will attack at the carbonyl carbon positive charge electrophile, and then we will get the oxonium ion alkoxide, cyanoalkoxide. This cyanoalkoxide then take protonation, proton from the HCl, and we will get the cyanohydrin as a product. This is the acetone also undergo reaction, and we will get the hydrox product where this cyanide will attack at the acetone carbonyl, and we will get the alkoxide ion with cyanide. This alkoxide ion in next step will take the proton from the HCl, and we will get the cyanohydrin and cyanide as a product. Now, the electromeric effect. What is the effect is there on the mechanism? So it is seen that, as we know, that any double bond or multiple bond which increases the electronegativity or polar nature in the carbonyl group will increase the reaction, and we will get a more polarity. So there are some important characteristic of this electromeric effect. So this electromeric effect is only temporary effect, and it will work when the carbonyl group is susceptible for nucleophilic addition reaction. Otherwise, this electromeric effect or the effect of the other group on the carbonyl group will not act or work. So this is a temporary effect, and in this the arrow shows that from where to where electrons is moving. So in the case of this carbonyl group, the electrons is moving towards carbon to heteroatom or oxygen atom, and we will get the partial negative charge as the heteroatom or oxygen and partial positive charge as the carbonyl. So any group or any electronic effect which increases the polarity of carbonyl group and make carbonyl group more reactive is a favorable effect. So if you see this alkene, carbonyl ketone and cyanide, in this case the alkene is a less reactive with compared to ketone and nitrile. Now if you see the direct shift of electron pair, in some cases what is happening, without any external effect or anything, directly the electron will move towards one side and polarity will be generated. For example, ethene. In the case of ethene, the pi bonds, the electron from one carbon move towards one carbon, and we will get the negative charge at one carbon, the other carbon will get the positive charge. So this is the direct electron pair move in the molecule. There will be no support or effect from the any other group, or there is no any other Lewis acid or any metal ion will be involved to generate the polarity. So in this case, direct electron pair internally will move and the polarity will be generated. So example is acetylene will generate this polar molecule where one carbon contain the negative charge, one contain the positive charge and electrophile, then nucleophile will be attacked. Now, types of mesomeric effects. So we can see that there are different types of mesomeric effect. One electrophilic effect, one is a positive electrophilic effect, one is a negative electrophilic effect. So the positive electromeric effect will increase the reactivity, or we can say will increase the polarity very positively. That's why they have the positive effect. The reaction will move very fast. So here see example ethylene. This protonation will make this molecule to undergo immediately the polarization and then attack of the protein. So in the presence of this proton, acidic proton, the polarity of alkene double bond will generate, and double bond will polarize and it will undergo then that protonation, that proton will attack and nucleophilic addition reaction will take place. Here same example is given and explained. Now negative effect, what happens in the case of negative effect, the nucleophile is directly attack on the double bond and it will react with the addition product nucleophilic attack, and then the negatively charged compound will form. So in negative endomeric effect, directly nucleophile will attack. In positive electromeric effect, the protonation or acid will generate the polarity. So these are the examples. When OH will attack on the ethene, so hydroxylation will take place and then the nucleophile or carbene ion will form. Cyanide will attack at the carbonyl group and cyano alkoxide will form. Then the cyano alkoxide will take protonation and the reaction will complete. Now, there are a difference between the inductive effect and electromeric effect. So, the inductive effect is a permanent effect, whereas the electromeric effect is a temporary effect. The presence of multiple bonds is not essential in the inductive effect, whereas in the electromeric effect, the presence of multiple pi bonds is compulsory. The polarity of bond is essential in inductive effect, whereas in electromeric effect, polarity of bond is not essential. It will be generated during the reaction. The partial separation takes place, whereas the complete charge separation takes place. Now, in the case of inductive effect, the number of ions are formed, whereas in the electromeric effect, ions are formed. In the case of inductive effect, no ions is formed, whereas in the electromagnetic effect, ions are formed. In the case of inductive effect, the attacking reagent is not required, whereas in the electromagnetic effect, the attacking reagent is required. Now, in the case of inductive effect, the displacement electron do not leave their molecular orbitals. However, distortion of electron will take place, whereas in the case of electromagnetic effect, the displacement of electron leaves their orbital and attain a new positions. They will migrate. Whereas in the case of last inductive effect, it involves mere displacement of the electrons, whereas in electromagnetic effect, it involves a complete transference of pi electrons. So with this, we have completed the introduction of the carbonyl compounds, and in next class, we'll go through the detailed reactions of the carbonyl compounds. Thank you.